Did you know that your web camera is similar to a remote sensing satellite? Today, I'm going to show you how to hack your webcam so that it sees infrared radiation. But first, let's start with this. Just beyond the visible spectrum, we find the infrared radiation. The way in which an object can reflect, transmit, and absorb the sun's near-infrared radiation can give scientists useful information about not only the health of crops, for example, but also soil composition and temperature changes on our planet. Today, I'm going to show you how to hack this web camera in order to allow it to detect this near-infrared radiation. This is an analog for what remote sensing satellites can do when they monitor our Earth's vegetation through infrared cameras. First, you're going to need a cheap web camera such as this one. And I've chosen this in particular because it has a manual focusing ring. This is useful because the entire focusing ring can be removed, allowing easy access to the lens inside, and more importantly, the infrared filter. Most web cameras have an infrared filter in order to increase the quality of the visual image. But of course, if we want our camera to be detecting the infrared radiation, we need to remove that filter. The first step will be to completely unscrew the manual focusing ring. Inside, you're going to see a small piece of tinted glass. You'll notice that it has a reddish-green tint, and it's exactly what we need to remove in order to allow our camera to detect infrared radiation. The easiest way to do this is by taking something sharp, like a small pin, gently inserting it into the side, and popping it up like so. At this point, please be careful, as depending on how hard the filter is stuck inside, it can shatter when you pop it out. Now that we've removed the infrared filter, we can reattach the manual focusing ring back into the web camera. Living plants have no real use for infrared light, therefore they reflect most of it. We can see this when we compare the image of a fake plant to that of a living plant. As you can see on the screen here, the fake plant is very dark compared to the brightness as we see in the living plant. The reason for this is that the living plant is reflecting majority of the infrared radiation, so that's what our camera is picking up. To begin with, I'm going to start with this plant here. I'll take my web camera, which I just removed the infrared filter, and I'm going to adjust it so that we have a clear image on the screen. You'll notice that the picture is very bright at the moment, and this is because the infrared light is currently flooding the camera. In order to minimize the amount of visible light that will be entering the camera, we need to block it out. In order to do this, we're going to use two pieces of polarizing filter. By cross-polarizing, we can block out the majority of the visible light coming in. Then all we need to do is attach it to the front of our camera. But first, we need to make sure that our camera is well focused on the image that we want to look at. Now that we have the cross-polarized filters on our web camera, we start to see that very little of the visible light is able to get through, but it still allows the infrared light to come through. We see that the fake plant here looks quite dark, and the real plant looks very bright. The reason for this is that real plants don't have much need for infrared radiation. Therefore, they reflect most of the light. When we look at images from remote sensing satellites, we notice that there are patches of darkness and of lightness. When more near-infrared radiation is being reflected from healthy living plants, it will show up as a bright patch on the image, indicating that the vegetation in this area is very healthy. In contrast, if more visible light is being reflected, it will show up as a dark patch in the image, indicating that the vegetation in this area might be unhealthy or perhaps dying off. The healthier the vegetation, the more near-infrared radiation is reflected, and the brighter it will show up in our image. This is just one of the many ways that we can use near-infrared radiation to give us insights into the health of our plants.